Hi guys, welcome to our next topic, which is operations with radical expressions. We've done this before, but now we're going to introduce variables where we can. Oh my gosh, I'm doing awesome today. So remember, like radicals are radicals with the same radicand. That just means the number under the square root symbol. So 4 root 7 and negative 12 root 7, that would be an example because the 7s match. Unlike radicals, don't have the same radicand, meaning number under the radical. So an example would be 3 root 11 and 2 root 5, because 5 and 11 aren't the same. All right, so let's jump into this. There's not that much to talk about. Again, we've done a whole unit on this previously, so this should be pretty straightforward, I hope. So let's look at one like this. We have, technically this is a 1 root 2 plus 3 root 2. Remember, to add together, what's under the square root has to match. So they do. And then I just add the numbers on the outside. So 1 plus 3 is 4. And then it's root 2. This would be like if I asked you what's x plus 3x, you would tell me 4x. And this is simplified because you can't take the square root of 2 and no perfect squares go into 2. Number 2. Well, can we add or subtract these right off the bat? No, because the 3 and the 12 don't match. So this is a case where you would have to simplify the 12. What's the perfect square that goes into 12? 4 times 3. The square root of 4 is 2. I have to bring down the subtraction symbol. And root 3 stays on the inside. Can you now combine these? Yes, because the root 3's match. So we keep the root 3. And then we just look at the numbers on the outside. So 7 minus 2 is 5. So my answer is 5 root 3. I can't simplify that anymore because 3 is not a perfect square and no perfect squares go into 3. Next one. Now you're going to also see ones with the distributive property. Again, we've done ones like this before, but let me refresh your memory. So we just distribute in the root 3 to the root 6. Root 3 times root 6 is root 18, because 3 times 6 is 18. And then I have to do root 3 times 7. Remember, 7 is not under a square root symbol, so it'll just be plus 7, and then the root 3 gets tagged on. Now, you can simplify this more, because there's a perfect square that goes into 18. 9 times 2. Square root of 9 is 3. I can't take the square root of 2, so that stays. And then the 7 root 3 stays. You should ask yourself, can you add these together? And the answer is no, because the root 2 and the root 3 do not match. So that is your answer. Number 4, here we go finally with some variables. Okay, so we distribute in root 2x times root 6x. 2 times 6 is 12. X times x is x squared. So it's root 12x squared. Root 2x minus 11. The 11 is not under the radical, so it'll be minus 11 root 2x. Now you can't do any simplification with the 2x, but over here, the 12, what perfect square goes into that? 4 times 3. And then like our lesson yesterday, we can't simplify we don't need to rewrite the power of 2 because it's even. So here I go. The square root of 4 is 2. I can't take the square root of 3, so that stays inside. And the square root of x squared, here I am blurry. 2 divided by 2 is 1, so I get a 2x on the outside. And then minus 11 root 2x. This is simplified all the way, and you cannot go any further because 3 and 2x do not match. Okay, number 5, using FOIL. We've done ones like this before. Remember, if it says a quantity squared like that, you're really doing that parenthesis times itself. And we've already done ones like this, but to refresh your memory. Here I go, FOIL. Root 7 times root 7 is root 49, which is just 7. Root 7 times 4, that's 4 root 7, plus another 4 root 7. And then 4 times 4 is 16. I can add the 7 and the 16 together to get 23. Now I can add these two together because your root 7's match. and I just add the 4 on the outside. So 4 plus 4 is 8. So my answer is 23 plus 8 root 7. Cannot simplify because 7 is not a perfect square, and no perfect squares go into 7. Number 6, now we do it with some variables. So same process. First, negative 5 times 3 is negative 15. O, outside, negative 5 times root 3 will be negative 5 root 3. Insides, I'm going to do the 3 times the 3 to get 9, and then the root 3x comes along. And then my last one, you're doing 3 times technically a 1 over here, which is 3. Root 3x times root 3, that's going to be root 9x, because 3 times 3 is 9, and the x comes along. Alright, so let's see what we can simplify. Can't do anything with the negative 15. Can't do anything with a root 3. Can't do anything with a 3 under the square root or an x. The only thing we can do something with is the square root of 9. So let's rewrite my line here. So I have this 3. What's the square root of 9? 3. And then root x has to stay. So cleaning this up, it's not pretty. My last term, 3 times 3 is 9, root x. So now I want to ask myself, well, can I add any of these together? Can I combine any of them? And the answer is no, because this has a root 3, this has a root 3x, and this has a root x. So nothing is exactly the same. You can't add those together. There's your answer. 2 more to go. Number 7, rationalizing a denominator. So again, we've done this before. To refresh your memory, I'm going to do it with numbers first. So some of you like to simplify before you rationalize, others don't like to. I'm going to take the approach of let's just get rid of these radicals. So if you remember doing this a couple months ago, we would multiply by what's called the conjugate. Do you remember that word? Of the denominator. What that means is you take what you see in the denominator, but you just switch the sign that's in between the two numbers. So because I have a positive here, over here I have to write a negative. And I multiply the top by the same number, because root 10 minus root 8 divided by root 10 minus root 8, that's just really 1. And we can multiply any number by 1 and not change that number. It's going to look different, but technically it's the same number. So on the top, what happened is you have negative 4, just to really emphasize what's going on here. You have that. And then in the denominator, what's going on here, just to really remind you what we just did, we have this. Okay, so I don't want to leave it like that. I need to simplify. So I'm going to distribute in the negative 4. So that becomes negative 4 root 10 plus 4 root 8 in your numerator. Now I FOIL the denominator because I have a binomial times a binomial. So root 10 times root 10, remember that is root 100, which is 10. And then I'm going to get a minus root 80. Some of you might remember the trick here. I'm going to get a plus root 80. And then a positive root 8 times a negative root 8. That's going to be a negative 8. Or a negative root 64, which would be a negative 8. Now, the point of multiplying by the conjugate, remember, of the denominator, is that it cancels out, it gets rid of the square root terms. So negative 80 plus 80, those cancel out. And that's the whole goal. If you multiply by the conjugate and you don't get rid of the square roots, you did something wrong. But let's clean this up a little bit. Root 10, there's no perfect squares that go into 10. But what about 8? Perfect squares that go into 8. To save myself some writing, that's 4 times 2. I'm doing really good here. So I have a plus 4. What's the square root of 4? 2. And then this 2 I can't take the square root of, so it stays inside. In the denominator, you have 10 minus 8 left, which is 2. So again, let me just clean this up here, showing you a lot of different steps. 4 times 2 is 8. And then I have the 2 on the bottom. So this is great, but we do need to simplify. You might notice that we have even numbers, but I want to remind you, you cannot cancel this 2 with this 10 or 2 with this 2, because the 2 and the 10 are under the square root. what helped some of you last time was to realize that this is really two fractions being added together. So if you need to see that step, I know some of you write that out. Kind of like when we did the quadratic formula. Okay, and this is where you say, well, -4 divided by 2, well, that's really just -2 and then the root 10. So again, you cannot cross out anything with the root 10 or the root 2 because it does not have a square root attached to it. And then 8 divided by 2 is 4 root 2. We cannot add these together because your radicands don't match. 10 and 2 don't match. That's your answer. Okay, so how is this going to look, our last one here of the lesson, with variables in it? So this one's actually not so bad, the one I picked here. So let's try to clean up what we have. Root 5n, can't do anything. But over here, can't break up the 3, but if you remember from our lesson yesterday, n to the 4th, 4 is even, so I take 4 and divide that by 2 to get an n squared on the outside. So I have n squared root 3 plus 5n. Well, that didn't get rid of my radical on the denominator. So I still have to multiply by the conjugate of the denominator. So I'm going to multiply by n squared root 3 minus 5n. Again, here it's a negative because I have a positive here. If this was a negative, this one would be a positive. I have to multiply the top by the same exact number because that is really 1, and you're not technically changing a number when you multiply it by 1. So to emphasize what's going on in your numerator, I'm going to just write it out. It looks messy, but we'll be okay. And then in your denominator, some people might argue it might have been easier to leave it in the n to the 4th, but it's okay. All right. So here we go, let's clean this up. We distribute in. This is really n squared times 1. So that's n squared. Root 5n times root 3, that's going to be root 15n. Okay, now I have to distribute this in here. There's no radical over here, so this will just be minus 5n, because of this 5n, times, a lot of 5n's going on, root 5n. Divided by, now in the denominator you have two binomials, so you have to FOIL. N squared root 3 times n squared root 3. Be careful, n squared times n squared is n to the 4th. That's your property of exponents. You add the exponents. 2 plus 2 is 4. Root 3 times root 3 is root 9, which is just 3. I'm going to write that in front of the n to the 4th because it's a coefficient. Now I'd like you to remember with conjugates the middle terms cancel. So I can save myself that work. But I might actually just, again, do it out to show you. So n squared root 3 times negative 5n, that would be negative 5 n squared times n, that's n cubed, because 2 plus 1 is 3. And then you had the root 3. I said this one was messy. Here, your insides, 5n times n squared, that's going to be positive 5n cubed root 3. And then 5n times negative 5n is negative 25n squared. So see, here we are again. Your middle terms cancel out. If they didn't cancel out, you did something wrong. So let's take a look in our numerator. Can you simplify 15? Meaning, do any perfect squares go into it? No. Same with 5. So nothing's going on there. Minus 5n. Okay. And then in the denominator, we have 3n to the 4th minus 25n squared. Cannot add those together because your exponents don't match. Now, I'd be pretty happy if you could get to this answer. I'm hoping some people out there might see that this can be simplified a little bit. If we look at our terms, this term, this term, this term, and this term, what do they all have in common? What's the greatest common factor, of all those terms, you should tell me is n. This has an n squared. Again, we cannot factor anything out of here. This has an n to the 4th, n squared. That means I basically can divide an n out of each of these. So dividing this term by an n will leave me with n root 15n. Dividing an n out of here will be minus 5 root 5n. Dividing an n out of here will be 3n to the third, and then this would be 25n.